India has achieved another major milestone in indigenous defense technology, with DRDO successfully completing the final development trials of the ULPGM-V3, the unmanned aerial vehicle launch precision guided missile. The advanced missile was tested in both air-to-ground and air-to-air modes at the DRDO test range near Kurnool in Andhra Pradesh. The trials validated the missile's capability to engage enemy's tanks, drones, helicopters and airborne targets with high precision using UAV platforms. The system was operated through a highly automated ground control system designed for command, launch and combat readiness operations. India's latest indigenous precision strike weapon has now demonstrated the ability to operate in multiple battlefield scenarios. DRDO validated both offensive ground strike missions and aerial interception roles during the trials. The missile was integrated onto UAVs developed by New Space Research and Technologies Bangalore, showcasing growing synergy between India's defense startups, private industry and DRDO ecosystem. The ULPGM-V3 has been developed by DRDO's research center IMRAT along with DRDL, TBRL and HEMRL labs. Bharat Dynamics Limited and Adani Defense Systems have partnered for the production. DRDO says that the missile has achieved a fully mature domestic supply chain, with MSMEs and Indian industries playing a key role in developing manufacturing. The successful trials significantly strengthen India's future unmanned warfare capabilities. It gives Indian forces the ability to launch precision attacks from UAV platforms without exposing pilots or frontline assets to direct danger. Its dual role capability also enhances India's preparedness against emerging drone warfare threats, increasingly seen in modern conflict worldwide. The successful development marks another decisive step in India's push towards self-reliance in advanced defense technology at a time when drone warfare and precision guided systems are reshaping battlefields globally. India is rapidly building indigenous capabilities to match future combat requirements, from anti-tank strikes to aerial interception missions. The ULPGM-3 reflects how India's defense ecosystem is moving from import dependence towards homegrown innovation and mass production readiness. On this issue, I am joined by Group Captain V.N. Jha, Senior Scientist, former Joint Director, DRDO. Sir, your opening comments on this development, sir.
Very good evening, Karthik. Look, this is the time for innovation, and either any nation to sustain its relevance in the world today innovates various technologies.
Yes.
Now, India also is no exception in this. And luckily, we have all the technologies which is required for mastery in the aviation, in the combat operations. And that is where our role, especially I'm talking of the DRDO. DRDO has been, the master piece in entire, say, missile systems or the missile operations or the aerial combat platforms that we can see. Besides, of course, naval and army also, we have got various labs which are doing a phenomenal job in this. But coming back to the opening address, what you have said that this particular missile Mark III is having this success. Well, we had foreseen it a long time back. Not that I have been part and partial of any such projects, but one such lab was in the neighboring building of me, where I was working in the DRDO. And so even if I know something, very intricate system, I won't be able to speak here on the public platform. But then I have not much of idea what all are going on there. Coming back to this,
you're adding a lot of caveats, which means that I'm talking about the real stuff here. I'm really talking about the cutting edge work which the DRDO, which means I've got the story right.
Look, any missile system has got 8 main systems. We call it propulsion, which has been very robust in India.
So, we all of us have, grown up watching stuff like Terminator 2 and, latest Hollywood films where, drones and missile capabilities have become one. Afghan theater demonstrated a sort of a different drone capability where America had actually suppressed, the air feature of the enemy. So, the predators could, loiter for hours and hours and hours and very easily could, take down the targets. But these drones, which are very different, these are battlefield drones. close combat drones. They bring a different dimension. I mean to say, in a battlefield, if these drones become operational, Indian drones, it means that it is going to empower our army so much. I mean, so then you are not dependent on helicopters or aircrafts. Then you can make close combat actually very lethal on a somber note for the infantry.
Absolutely. Look, Karthikeyan, I have seen you, talking to the walking dictionaries of who and who in military, and they have all told you, and you have conveyed through your platform, that the battlefield scenario is right now changing so rapidly that what the modus were applicable, relevant, effective yesterday may not be effective in the day to day or even tomorrow. So what is happening is here is that the UAV has made that entire battlefield change in a very rapid succession, and that is where the role of Ukraine and Russia is the burning example.
Yes.
What drones they were effective in the beginning of the warfare. Today it is no more effective. They can be shot on every left, right, and center. So that is where it comes, and that is where I was trying to tell you that in the missile technology, which either it could be a suicidal drone, kamikaze drone, or it could be a launch platform like what we have tested in the DRDO. That there is a drone. On that drone, we have fitted the missile system, a very small, lightweight missile system, equally effective, which can do the same role what aircraft-borne missiles are working. Scalp, Hammer, you keep on naming BVR missiles and everything. All those roles can be handled by these small drones in a very small thing. That is where I was trying to tell you that missiles, any missile, have got essentially 8 basic systems. Propulsion, what was there today for giving them the range. Yes. Today there's a need for a modular propulsion. If I want to fire a missile from a drone platform, which is 2 kilometers or 3 kilometers or 4 kilometers, it need not have that 50 kgs of combustion system, propulsion system. Similarly, aerodynamic control, it becomes very intricate. Navigation control in 3D, that is the absolute necessity. And in the aerial platform, most of our time goes into certifying and the Q&A, quality and assurance of the particular system that we develop. I have gone through this. I have developed 12 systems. I know how painfully staking it is there. But in the drone platform, you don't have to have such rigid certification what goes through the CEMILAC. We have got in the military, we have got the CEMILAC, Center for Military Airworthiness, that we have to prove for every system. Even a gun, a bullet, a missile, a
yes.
rocket, you name anything. It has to be first certified to be fitted into that aircraft. But aerial platform, UAV, should have exception, and the policy makers, people who are behind the entire R&D, they should insist that here is a platform where we don't have to waste so much of it. It is not a wastage of time. It is ensuring the quality areas. But also, sir,
it will also have the capacity to overwhelm the system. Imagine if there are 100 such drones with 100 such mini missiles, and barely traveling 5 to 10 meters above the ground. It can be overwhelming because even the radar signatures would become impossible.
Absolutely, it can fly just 10 meters. It is a slow operating system.
So they become impervious to radars.
It can fly 10 meters, 20 meters, 30 meters above the surface, avoiding the terrain, avoiding the tree tops, and that is where it can be so effective. It can overwhelm the entire system. And then to fit in those small UAVs, quadricopter or a fixed wing UAVs, you don't have to have such a robust militarily certified systems. So that is where comes the role of a missile system, which can be made very rapidly using our own system, further miniaturizing the system that we know of, especially the navigation control, integrated computation system, guidance system. These are the 3 systems which are so costly. This alone cost about 70% of the entire missile. So we can now our own chips are coming up in the market, are likely to come in the market. So over a time, we can look into that entire area. We can make the systems, these three systems, navigation, ICS, and the guidance system, so useful, low price, that within.
Sir, I think sorry, I've run short of time, but I think the meat of the story is in the indigenization. If Iran can create a Shaheed, our tech system, our human resource system is far better than those countries, and for a system like this, I think it should give Pakistan shivers. If we have been able to indigenize a system like this, put it in operation, then it should give Pakistan shivers.
Just give me one sentence. Look, we should not go back to the Iranian technology. Iranian technologies are a decade back. Right now, we have got a system which is operating today. Last time I had met you, I had told you that we have been a part of a new system which is coming up in the drone technology.
Yes.
I have been witness to that particular thing.
Okay.
We have given many suggestions. Here is a role of armed forces. That Mark 1, Mark 2, Mark 3 with the newest of the systems will come subsequently. But what is readily available today, utilize that.
Okay.
That is how today you meet the requirements of today specifications. When we started the specification, if any system meets
absolutely, but I think today, it's a great achievement. I think it's a great achievement, and it's a happy day. And on this note, I close this conversation with you. But to my viewers, don't go away, because after a short break, I'll be back and we'll talk about silent heart attacks in young adults.
First Battle of Panipat, 1914, Madhubani.